Hi everyone, this is Lab 9, Spatial Interpolation. In step 1, in ArcGIS Pro, insert a new map frame and then rename it to Lab 9 task. So right click the map data frame, go to properties and then change the name to Lab 9 tasks. Click OK. Step 2, add ANSI station sample and ANSI boundary to the contents pane. So go to your Lab 9 folder and then add ANSI boundary to the current map and then ANSI station sample also to the current map. So once you have added them from the catalog to the contents pane, in step 3, in the ribbon, click on Analysis tab, and in the Geoprocessing group, click on Environments. Under workspace, click on the folder next to current workspace and set it to Lab 9 folder. It is already set to Lab 9, so I am not changing it. And then do the same thing for the scratch workspace. It is already Lab 9. I am not doing anything to it. And in the environments dialog under processing extent, click same as layer ANSI boundary PRJ. Click OK. Step 4, in the geoprocessing pane, search for IDW. So go to Analysis and then Tools and then search IDW. IDW Geostatistical Analyst Tools. And for the input features, use ANSI station sample. Z value field will be ANN PRCP. Output geostatistical layer is IDW Geostats. Output raster, leave it blank. Output cell size 6000. Power 2. Source neighborhood, we'll be using standard, which is the default one. And then maximum neighbors 15, minimum neighbors 10. Sector 1 sector. Angle 0. Leave both major semi-axis and minor semi-axis to their default values. For the weight field, leave it blank and then click run. You can see that the IDW geostats layer is added to the contents pane. In step 6, right click the IDW geostats layer and then click open. Step 7, in the geostatistical wizard, click on the click to optimize button next to power. So click to optimize, and then this gives you some values. This is the suggested power value that the ArcGIS Pro optimizer will suggest. So you can answer question number 1, and when you answer this, round to 2 decimal points. And then you can answer question number 2. Then in step 8, the graphic frame to the left in the geostatistical wizard shows station points and their weights, which are shown in color symbols. Now click on different parts of the interpolated surface. So you can use the Explore tool for that. So go to Map and then use the Explore tool. And then you can explore them to know the values for the prediction. So you can choose the different parts of the surface and get their corresponding prediction values. You can also check the weights that are used for each control points. So go to the arrow next to weights. So you will see 15 neighbors. The larger weights are given to the control points which are closer to the interpolated cell than those further away. And in step 9, click next. Step 10, the cross validation portion of the geostatistical wizard allows us to draw scatter plots relating the predicted to the measured values at control point locations, predicted tab, so you can explore them. So you can also look at the error tab. And then in step 11, once you are done with the observations, you can click finish. So this will give you the method result and also summarize the parameters you chose for the interpolation. Once you observe those, you can click OK to close it. Now we will convert the IDW geostats layer to a raster and then call it IDW grid. For that, in step 12, right click the IDW geostats layer and then export layer to rasters. Step 13, in the GA layer to rasters pane, enter 6000 feet for the output cell size. So output cell size is 6000 feet and you specify IDW grid for the output raster. So change the output raster name to IDW grid. Step 14, click run. In step 15, we need to clip IDW grid by using ANSI boundary PRJ. So for that, first go to analysis and go to tools and search for extract by marks tool. So input raster is IDW grid. Input raster or feature marks data is ANSI boundary PRJ. Name the output raster IDW underscore precipitation. Let the extraction area be inside and leave the rest of the options to their defaults and click run. Step 16, change the symbology of the IDW precipitation. For that, right click the layer for IDW precipitation and then go to symbology. Step 17, in the symbology pane, choose classify for the primary symbology and set the method to natural breaks and 10 classes. You can choose a color scheme that goes from light to dark of the same color. So you can choose the color scheme. For instance, this one. And then we want to reverse the symbol order so that it is from light to dark. So we start with light color and then the larger values will be the darker color. And then finally, we will create a contour layer from IDW precipitation. You can read the documentation and then you can answer questions 3, 4, and 5. So let us now create a contour layer from IDW precipitation and label the resulting isolines. In step 18, go to analysis, tools, and then search for contour. Select contour, spatial analysis tools in step 18. Step 19, select IDW precipitation is your input raster. Name the output raster is IDW contour. Enter 5 for the contour interval and 0 for the base contour. Click the info button to the left of the contour interval and also click the info button to the left of base contour, and then you can answer question number 6 and 7. Step 20, click run. Step 21, click on the IDW contour layer and in the ribbon go to labeling. Step 22, in the label class group, select contour as your field and click on label button in the layer group. You can now see the map now contains the labeled isolines. So you need to prepare a map showing IDW precipitation and IDW contour. For that, go to insert and new layout and choose your layout for the map. Choose the map frame. You can activate it to the desired scale, and then when you are done with activation, close activation. And then you need to have all the map elements such as north arrow. So go to insert and then add north arrow and then add legend, add scale bar, give your map a title, and when you are done with preparing the map, save your map. So go to share and then export layout. Choose the file type is PNG and then give the map name, and then you can export your map once you are done with it. Question number 8 says, what is the range of contour values in IDW contour? So open the attribute table for IDW contour in order to answer this question. So you can see the range of the contour values here. You can sort it by ascending. Now you can see the range of the contour by looking at the values that are shown in the attribute table, and you can answer question number 8 and then answer question number 9. And yeah, that's all. This is the end of lab 9. Thank you.